video is on ice charts. An ice chart is used doing equilibrium calculations when you're not given equilibrium concentrations, but rather you're given the initial concentration of either the products or the reactants listed in your equilibrium reaction. So, we use initial concentrations, not equilibrium concentrations. Ice stands for I for initial concentration. C is for change, and this is a stoichiometric change that is dependent upon the mole ratio given to you in the balanced chemical reaction. E stands for your equilibrium concentration, which is what we're trying to find. So in our example, we have the equation listed here with a K value of 0.016 at 800 Kelvin. It says that 4 moles of HI are placed in an evacuated 5-liter flask and then heated to 800 Kelvin. The system is allowed to reach equilibrium. What will be the equilibrium concentration of each species? So we're going to let X represent the change in concentration of the hydrogen gas. Since we start with HI alone, the reaction must proceed to the right, resulting in the increase in the amount of hydrogen gas. So we are told that we have 0.800 molarity, or concentration of our HI. We don't have any hydrogen gas, nor do we have any of our iodine gas. Because I'm starting here, my reaction is going to proceed to the right, so I'm going to end up with, I'm going to decrease by some amount, X. And because I have a 2 in front of my coefficient here, I'm going to decrease by 2X. I'm going to increase each one of my my products by X. And it's just X because their coefficient in front is just a 1. So then I summarize what I have. My concentration given from 4 moles divided by 5 liters. So 0.800 minus the 2X, and then X and X. Now I'm told my K value, and I know already from my K expressions that K is equal to the concentration of my products divided by the concentration of my reactants raised to their coefficients. So my K is going to be over my products. And because of the 2 in front here, there's going to be raised to the second power. Now I plug in the information given to me. My K value, which is equal to my X's, each one here, I'm going to use my equilibrium amounts, X's, and then for my HI, my 0.800 minus 2X. And all of that is squared. So when I put these two together, I have X times X on the top, which is X squared. That allows me to take the square root of both sides to get rid of my squares. So I'm going to take the square root of my first value and the square root, my X squared over and when I plug that into my calculator, I get 0.126 is equal to X over 0.800 minus 2X. Now this is like over 1, so I can cross multiply. So I have 0.126 times 0.800 minus 2X is equal to X. And now I'm going to distribute. Now I'm going to add 250 or 0.252x to both sides. So, I'm going to bring this up here. 0.1008 is equal to 1.252x. And I divide both sides by 1.252. And I get x is going to equal 0.0799 is equal to x. Now what does this value mean? That's the important part. Well, this means here this x gets substituted back in here, and into here. So that means my concentration of hydrogen gas, which is also equal to the concentration of iodine gas, is 0.0799 molar. My concentration of HI is equal to 0.800 minus 2 times 0.0799, which is equal to 0.800 minus 1, or 0.1598. When I plug that in, I get a final concentration of 0.640 molarity for my excuse me, my HI.